Okay, it says we're recording. All right, so just as a reminder this week, we're going to cover 8.3 today, which is geometric series. We're going to skip to 8.6 tomorrow, which is binomial. Thursday, we will have a review. I will try to get the review up after class today. I think I just need to publish it. And then excuse me. I don't know if I got my days right. Today is 8.3, excuse me. Today is 8.3, tomorrow's 8.6, Wednesday is the review, Thursday is the test. So, and then next week, they did finally post the review sheet. So I'll probably, on Thursday, well, I could maybe post it a little earlier if you want, but probably I will post, the UVU has a kind of a special study guide that they're going to be, that we can hand out. So it'll probably take some time. It's a pretty thorough review. So I'll probably post that for the weekend. And then if you guys want to work on that over the weekend, next Monday, we'll go over the test results. And then and then you guys can say, yeah, I saw this problem, I didn't know how to do it or something. So all of next week is just going to be review. I think I will still find an old final exam from Salt Lake Community College that'll be a combination of multiple choice and show your work, because that's how they do theirs. But anyway, so I'll probably have some different things. I'd also encourage you guys, the previous reviews that I've posted I think are really good. And so I'd recommend that if you want to review those would be really good to do too as well. So any questions about going forward at this point?
When is the final?
Oh, when is the final? So normally, that's a good question. I think our final, I think I'm going to do the same thing. Let me look at my calendar here because I can't remember when it was originally scheduled. I think it's Monday, isn't it? Monday the 27th. Yeah. So originally, if we followed the school schedule, this class would be from 9 to 11 a.m. And so I'm going to do the same thing. I'll give you 5% extra credit on the final if you take it between 9 and 11 a.m. on Monday the 27th. I will have it open all day on the 27th. But yeah, if you can take it between 9 and 11 a.m. on the 27th, I will, I'll give you 5% extra credit on it. And yeah, that'll be good. So it's hard to believe that we've just got 2 weeks left. Really? No, I guess 2 weeks and a day, basically. So yeah, we'll just plan on our regular Monday during finals week for that. Any other questions? That was a good question.
Sorry, I jumped in a little late. We still have a test on Thursday, right?
Yeah, I mentioned that. So
right,
still test on, so yeah, so a quick review one more time. 8.3 today, 8.6 tomorrow, review Wednesday, test Thursday. The following week is all going to be review, so I'll give you some stuff that you can do at home, and then we can answer questions in class. And then Monday, the 27th, is the final exam. So 2 weeks, literally 2 weeks from today. Okay, any other questions?
Do we get our lowest test score dropped? Or is that something I heard in another class? I might have mixed it up with you.
Yeah, so that's another good question. So yes, I will drop your lowest test score. I'm trying to decide. Here, I'll make this a democracy. Normally, I still make you guys here. You know what? Here's what we're gonna do. Rather than have quizzes next week, I'm just gonna see if you guys show up, and if you show up to class, I'm gonna give you. If you show up on time, I'll give you one more point than if you just show up. How's that? So that will be the quizzes. So the quizzes will be just coming to class and asking questions next week. But I will still have quizzes for this week. So once I do that, so probably on Monday the 27th is when I will actually update Canvas to match. I do know that one of the students said that the file that I had posted didn't work or something. She said it didn't have access. So I created a new file that actually had, I modified the spreadsheet a little bit because a lot of people are like, what's the best I can do? What's the worst I can do? And so I put 100 on the next test and I put 0 on the last test. And then let's see, 100 on the next test and the final, and I put 0 on the next test and the final so you can see what your grade would be. And of course, in fact, let me show you that really quickly. Is it here? If you go to announcements, now the scores in here are not your scores. They were just for testing purposes. So if you download this file, just go ahead and enter in your current quiz average, whatever it is. Enter in your 4 tests just as they are. You'll have to guess on your 5th test. That's why I put question marks there. What it'll do is it'll tell you your adjusted quiz average. So if this was your scores, if you had a C average 74.65, your adjusted quiz average of 93 would replace your lowest test, which in this case would be the 69. So the 93 replaces the 69. That gives you an adjusted score of 78, which is a C+. I have to guess what your final exam score is going to be, so I put just whatever that is, whatever the average of those are, and that's so that's that score. And then this is your current grade. So if these were your scores, let's just pretend these are your scores for a minute. So you don't know what you're going to get on test 5, but if you got 100 on test 5 and 100 on the final, you could bring your grade up to a B+. And if you got a 0 on the test 5 and a 0 on the final, you're going to fail the class. You're going to get a 54%. So you will be somewhere, these are your best and your worst cases, that you can be somewhere between failing the class and a B+. You can guess whatever you're going to get here. 80. Oh, you got to enable editing now. So if you did 80, that's what it would be. If you got a 0, that's what it would be. If you did a 55, whatever, you can just do. So the 93 replaces the 55. That's why the score didn't change. If you got 90, anyway. So anyway, you can just kind of play with that. Just enter in all your scores, and then guess what you're going to get on test 5. And it will do that. Any other questions? All right. So, yeah. So once we have all the quizzes entered, then I will have it. Then Canvas will match the spreadsheet essentially. Okay. So that probably won't be till next week. All right. So today we're going to talk about 8.3, which is geometric sequences. I'll make this a little bit bigger. All right. So, so the main thing about the A is the first term, and R is the common ratio. And the basic formula that you're supposed to know is, I'll make it a capital A because I can't do subscripts. So A sub n equals A, I'll make it a capital A again, A times R to the n minus 1 power. Okay? So that will be the formula that you want to remember for this class. Okay? So let's do an example. Let's say that A equals 3 and R equals 2. Can you find A sub 1? And let's ask, we'll start at the bottom of the list today. Sam, can you tell me what A sub 1 equals with this?
You multiply A by R is going to be 6. And then
Oh, it's not
the
going to
power-
be, no, you actually did that wrong. So that you're going to take your A, which is 3, and you're going to multiply that times 2 to the
It's going to be
1 minus 1. So what's 2 to the 0 power?
2 to the 0 power will be 1,
1. So 1 times 3
3.
is 3. So don't multiply the 3 times the 2 right off the bat, because you
Okay.
said 6 originally. Yeah. Okay, so A sub 2 equals, here, I'm going to do this. Who can do A sub 2? How about Nathan?
So would it be just similar except plugging in a 2 there? So 3
3 times
2 to the 2 minus 1.
minus 1. So 2 to the first power is
2,
2 times 3,
6.
6. Perfect. A sub 3 equals, must be Natalie's turn.
Okay, so this would be 3 times 2 to the 3 minus 1, which is 2 squared. So 3 times 4, and that's 12.
Perfect. Okay, oops, except for I wrote it wrong. 3 minus 1. All right, A sub 4 equals, whose turn is it now? It's Max's turn.
Yeah. So it's 3 times 2 to the 4 minus 1 power.
And 2 to the third power is
8.
8 times 3.
32.
No, it's
Wait,
24.
8. 24. Sorry.
Good thing you got your calculator for the test, right?
Yeah, it's in the.
All right. Okay, so well done. Let's do this in the reverse order. Let's say that I had a sequence 5, 15, 45, 135, etc. And the formula. So in order to find the formula, we need to find the first term and then the common ratio. And so Logan, can you do that? What's the first term?
First term is 5.
5. And the common ratio?
Is that 5 or 3? It'd be 3, right?
It would be 3, right? Yeah. Each term is multiplied by 3. So 5 times 3 is 15. 15 times 3 is 45. 45 times 3 is 135. Okay, so now can you plug it into this formula right here? So a sub n equals,
Equals 5 times 2 to the power of n minus 1.
2. Where did you get the 2 from?
I meant 3. My bad.
3.
I was looking at the
There we
wrong.
go. 5 times 3 to the n minus 1 power. Perfect. Okay. Well done. All right. Could you find, now that we've found the formula here, I'll highlight that in green. How's that? Could you find a sub 8? And let's ask Landon.
Sorry, I was still writing down the formula, but you're essentially going to plug in 8 for n, right?
Correct. So how would you set it up?
So it's going to be 15 to the
No.
8 minus 1.
No. People keep making that mistake.
Okay.
Don't multiply the 5 and the 3 together. It's going to be 5 times 3 to the...
Oh, got it. My bad. To the 7.
To the 7th, or 8 minus 1 power. And 3 to the 7th power is a very large number. 3 to the 7th power is 2187, and we'll multiply that times 5 to get 10,935. Okay? All right, so yeah, remember, don't multiply the base times the first number. Okay, so let's do another good, even harder one. Let's say that a sub 3 equals, and I'm going to write it this way, 63 over 4, and a sub 6 equals 1 divided by 32. And I'd say find the 5th term of the geometric sequence. Okay. All right, so this one's going to be a little bit harder, right? But we know that in this case, we don't know what A is, but we know that we know our formula over here, the yellow formula. A times R to the n minus 1. I'm going to write this as R squared. Oops, I didn't mean to do that. A times R squared. And we know that this one is A times R to the 5th. Disagree with that? Okay. Now the cool thing is, if we divide both of these, A divided by A is going to be 1, right? So we're going to get 1 in the numerator, 1 divided by R cubed. Is going to equal those two fractions divided by each other. So I'm going to rewrite this as 63 divided by 4, and then the other one I'm going to write as 32 divided by 1701, because you can flip the second one, right? Okay. So if these are both fractions that we are now multiplying together, okay, since I've got 1 over R cubed, I could invert both of them. I'm going to write this as R cubed over 1, okay? Now, the other thing that I can do is 4 goes into 32 8 times, right? And so the 4 is going to go away. I'm going to have 1 divided by 63. I'm going to have 1701, divided by 8. Because I flipped both of these fractions, and I took the 4 and the 32 because I knew that goes in 8 times. Now, I have a feeling, a very strong feeling, that 1701 divided by 63 is going to go an even number of times, which is 27. So essentially what I've got here is I've got r cubed equals 27 divided by 8. Okay. Now I can take the cube root. So the cube root of both sides, r, is going to equal cube root of 27 is 3, cube root of 8 is 2. And so I've now figured out my ratio. My common ratio is 3/2. Okay? So now I can plug it back into this formula here. And I can say that a sub 3 equals a times 3/2 raised to the second power. And of course that equals 63 divided by 4. Well, 3/2 squared is 9/4. Oops, I should have left that alone. 63 divided by 4. 3/2 is 9/4. So if I multiply both sides by 4 over 9, 4 over 9, I say, the 4's cancel. 9 goes into 63 7 times, and therefore a equals 7. Okay. So the formula here is going to be a sub n equals your first number, which is a, times your ratio, which is going to be 3/2 to the n minus 1 power. Okay. Does that make sense so far? And therefore a sub 5, that's what we really wanted, a sub 5 equals this right here. Instead of the n, I want a 5. So 5 minus 1 is 4. So this is going to be 7 times 3/2 to the 4th power. So 7 times 3/2 to the 4th power. Now 3 times 3 is 9. 9 times 9 is 81. So I'm going to have 81 in the numerator times 7. Whoops. 81 times 7, which is going to be 567. In the denominator, I'm going to have 2 times 2 is 4. 4 times 4 is 16. So this becomes 567 divided by 16. Okay? And there is your answer for a sub 5 equals a sub 5. Does that make sense?
So you first multiply the 64 or 63/4 and the 1701 over 32. Is that what you did right there?
No. I actually divided.
Oh, you divided. Okay.
Yeah,
okay.
that's why I got a
now,
fraction there.
now it makes sense. Okay.
Yeah, you divide. Now, so that gives you 1 over r cubed. And so that's the first number, 63/4. And then when you're dividing the fractions, you multiply by the reciprocal. So
Right,
we take the
yeah.
original division into a multiplication. But yeah, okay?
Okay. All right. Yep. Thanks.
Okay?
Professor, can you
Yes.
explain how you got equals 7?
Yes, okay. So as we keep going here, so we've got 1 over r cubed equals 63 over 4 times 32 over 1701. So the 4 goes into 32 8 times. Now I'm going to flip the reciprocal. I'm going to take the reciprocal of everything. And while I did that, the 4 goes into the 32 8 times. So then we get r cubed equals 1 divided by 8. And then I've got 1701 divided by 63. And when you divide the 1701 divided by 63, you get 27. Does that make sense? So that gives me
Yeah, no,
27
I got the 27
over
part. I
8.
meant the 7.
You meant the what?
The A
7 part?
equals 7.
Okay.
Yeah.
So I've got r cubed equals 27 over 8. Cube root of both sides, r equals 3/2. Okay, so now I can plug it back into this formula here. And I know that a sub 3 equals this. And those are the smaller numbers, so I'm going to pick that. So if I take a sub 3 equals a times r, and we just figured out that r equals 3/2, to the second power, because it's 3 minus 1 is 2, that equals 63 over 4. Well, 3/2 is the same, 3/2 squared is the same thing as 4/9. So if I multiply both sides by 4/9, so the 4 in the denominator here cancels the 4 in the numerator here, and I'm going to get 63 divided by 9, which is 7.
Okay.
Does that make
That,
sense? Yeah. So that's how you get your A. All right, any other questions? Okay, so now all right, so now I'm going to give you two formulas here. So these are geometric sequences. Okay, and let's do the sum of geometric sequence. Okay. Now the sum of a geometric sequence okay, so there's two formulas. Okay, and so let me do this one. Use this formula if r, maybe I should say the absolute value of r, absolute value of r is less than 1. Okay. So if it's a fraction, basically. Well, I guess I shouldn't say if it's a fraction. If it's a fraction less than 1. And so this s equals a divided by 1 minus r. And so I'll make that look like a fraction, okay? So that's one formula that you're going to want to remember. And use, and we will also say that in this case, it converges. Now the other formula, use this formula if the absolute value of r is greater than 1. And so this formula S sub n equals a, which is your first term. Here, I'm going to move this over. S sub n equals a times, your numerator is going to be 1 minus r to the nth over 1 minus r. Maybe I should put that in parentheses so it'll line up better. I need to finish off that. And of course, this formula is on page 611. Maybe I should put that on there because it looks a little strange here. Page 611. So you can see the formatting is going to look better. Okay, so this is the other formula that you're going to want to know. And in this case, it diverges. And here's what I mean by converges and diverges, okay? And in fact, I'm going to show you this first formula. I'm going to show that 0.9999999, it goes on forever, equals 1. Okay? And here's how I'm going to do that. So what I'm going to do is I'm going to write this as the fraction 9/10. Maybe I'll write it this way, 9/10. That's the same thing as 9/100 and 9/1000 and 9/10,000, etc. Okay, so you can see here, let me underline all of these. You can see here that I could write 0.999 as a bunch of, as a series, right? 9/10 plus 900 plus 9,000 plus 9/10,000 plus 900,000, etc., etc. It goes on and on. Okay. Now, according to this formula here, the sum, if this is my geometric sequence, if I'm just adding all of these together to get the decimal point 9999999, okay, all I need to do is I need to take the first term, which is 9/10. 9/10. I'm going to take that and I'm going to divide it by what's the ratio on this sequence that I just had here. Let's pick on Caitlin Lucas. Must be your turn. Based on this sequence right here, what is the ratio?
Is it 1/10?
It is. I feel like I'm playing Jeopardy because I ask you guys questions and then you just say, is it? All right. So you can see here that the ratio is 1/10. Okay. So according to this formula, I said, first of all, so this ratio is less than 1, right? It's in between 0 and 1. Okay, so according to this formula here, I'm going to take this, I'm going to divide it by 1/10. Okay. So of course, when you take two fractions, you're going to take 9/10, and then you're going to flip the other one, 10/1, or it's actually 1 minus 1/10, sorry. 1 minus 1/10, right? Which is going to be 9/10. So oh geez, that didn't work out right. So 1 minus 1/10 is 9/10. So 9/10 divided by 9/10 is 1. So I just showed that 0.9999999 on forever equals 1. That's kind of cool, huh? You knew it was close to 1, and I just say, yeah, it actually equals 1 if you took it on all the decimals infinitely. So does that make sense? And so, so what's cool about this? Now let's talk about these two formulas for a minute. Okay. If I take 1 minus r to the n, if I have a fraction that's less than 1, like this one. So if I took 1/10 and I raised it to the 1,000th power, let's say, that's going to be a number very close to 0. In fact, it's so close to 0, Excel just called it 0. Okay, so essentially, when n gets really large, if your ratio is less than 1, then essentially this r sub n just goes to 0. And essentially, you're going to have a times 1, which is just a divided by 1 minus r. So these two formulas are actually the same if your ratio is less than 1. Now, that's not true if your ratio is 2. And so let's say, for example, I had a formula 1 plus 4 plus 16 plus all the way until you get to 4,096. Okay. So what's your common ratio in this series here? Let me ask the other Caitlin Janes. Can you tell me what your common ratio is on this sequence?
3 times 4.
Exactly. So R equals 4. 4 is greater than 1, so I'm going to definitely have to use this one. Now, in order to use this formula, I need to figure out how many are in my term. So my first term, here I'll ask Caitlin again, what's your first term in the sequence?
1.
1. Okay. And then do you know how to figure out your n?
Use the second equation.
Well, we're going to have to use this second equation to figure out the sum, but I need to figure out the n in order to figure that out. So are there any old equations that we learned earlier today that might be helpful for that?
Probably.
How about this yellow one right here?
Yes.
Okay, so we're going to use that formula. We know in this case that 4,096 equals A, which we know in this case is 1. So 1 times R, what's my, and my R ratio is 4 in this case, to the n minus 1 power, right?
Yeah.
So really, I don't need that first one in there at all. Okay, so 4 to what power equals 496? That's probably easier. We could probably just do a trial and error thing on that one. 4 to the 10th power is a big number. 4 to the 9th power, to the 8th power. Oh, we're only going to get 4 to the 7th power. Oh, we're getting one more. 4 to the 6th power. So 4 to the 6th power is 4,096. So if n minus 1 has to equal 6, what does n equal?
7.
7. Okay. So now we know what n is. Okay. So now we're going to plug it into here. We're going to get the sum of the first 7 terms equals A, which is 1. So I'm not even going to write it down, times 1 minus R. R ratio is 4 to the nth power, which is 7, divided by 1 minus 4. Okay. So this becomes 1 minus 4 to the 7th power, which is a big negative number, and 1 minus 4 is negative 3. So if I take the numerator divided by the denominator, the sum of the first 7 terms in this sequence is 5,461. Okay? Does that make sense?
So I have a question real quick.
Okay.
So like on a test or a quiz, like how will we know when to use that formula? Like will you say like specifically find or use the S formula or use the formula of are in absolute value or something like that? How will you phrase that?
So I'm trying to decide here. I think they do let you use a couple of formulas on here, but I need to double check with the math department. I might give you these formulas on the test. I haven't decided yet. It seems like I know. Here, let me just say this. If I look at my old Salt Lake Community College finals, let me see if I can find those. There they are. Old finals. Oh, this is the formulas that Salt Lake Community College gives you. So I would assume, well, I think they give you more than we give you. I don't know if they are, but I do know. So this is the formulas they give you. They don't give you any context. So this is your arithmetic sequence. This is your geometric sequence. You're going to have to recognize that those aren't going to be labeled. This is going to be your sum of your arithmetic sequence. This is going to be your sum of a geometric sequence. And this is the sum of, well, so they don't even tell you. So I'm pretty sure that UVU is going to give you all of these formulas, but you need to understand which ones are geometric. So essentially, these three on the right here, these are geometric, and these are arithmetic right here. And so I'm pretty sure that UVU is going to do the same sort of a thing, that we're not going to give you any context, but we will give you the formulas. And so you'll need to understand that. And I got an email. I need to read it because I need to follow UVU's rules. But at any rate, we can give you all these formulas, and you need to understand, oh, this is the formula here that I'm going to use for a geometric. Oh, why didn't it do that? I used to be able to draw this box on there. This is the formula you're going to use when your ratio is less than 1. And this is going to be your formula you use when the ratio, well, you can use it when it's less than 1, but it's more useful when it's greater than 1. And so, so let me do an example here, and I'm going to try to use this with the summation notation. So let's say that I had the sum from K equals 1 to 6 of 7 times -2/3 raised to the K minus 1 power. Okay, so here's what I'm going to do. Can I put this next to it? Oh, that's kind of small. I apologize. But do you know which of these formulas you would use to find this? And I'll open that out for anybody. I think we're out of time. So look here, your ratio right here, that's less than 1, right? That's your R term. So we're going to use this formula right here. So the sum of your first 7 terms. So in this case, S sub 6 equals A over 1 minus R. Here, I'll write it over. A over 1 minus R. Okay. So we need to figure out what your first term is. So your first term is K equals 1. 1 minus 1 is 0. So anything with 0 power is 1. So A equals 7. So I have to figure that out myself. And then I need to, so now I've got S of 6 equals 7 over 1 minus negative 2/3. Okay, so that's 1 plus 2/3, which is 5/3. So that becomes 7 divided by 5/3, which is the same thing as 7 times 3/5, which equals 21 over 5. So that's your answer. Okay, does that make sense? You know what? Actually, I think I did that wrong. Because that's not an infinite series. Actually, what I did, this would be true if it was infinite. But this is not infinite. I've got a 6 there. So let me back up a second. I'll start erasing stuff. So we only need to do the first 6 terms. I was kind of right. Okay, so because we're only doing the first 6 terms here, we're going to do, so this is going to be 7, we still figured that out, times 1 minus negative 2/3 to the 6th power over 1 minus negative 2/3. Okay. And so the sum of those in this case is going to equal 7 times 1 minus 64 over 729 all over 5/3. And if you plug that in your calculator, you're going to get 3.83. That's actually the sum of the first 6 terms. Okay. The first thing that I did was correct if it went to infinity. It will never get larger than 21/5. Is there any questions on that? I'll take that as a no then, plus we're out of time. So quiz tomorrow will be on 8.3. And so we'll see y'all tomorrow.
Thank you.
Adios.